You're welcome once again to my YouTube channel. Thank you for stopping by. If it's your first time, I'm glad you're here. If you are a returning viewer, thank you for coming again. Please do subscribe. Now, let's get right into this question. Remember, this is a continuation of the questions we've been answering on circles, arcs, and sectors. If you're in doubt about what to do or you need to quickly brush up the basic concept, please check the link in the description box. We have quite a number of videos that came up before this on this concept. Now, this particular question is talking about a sector. Okay, we have two sectors actually. The diagram shows two sectors of a circle. The major sector is shaded. When we talk about major and minor sector, we're just talking about the size. Okay, so the bigger sector is referred to as the major sector, while the smaller one is referred to as the minor sector. Okay, so in this particular question, we have a minor sector with an angle of 41 degrees and the major sector. Remember, the sum of angles in a circle is 360 degrees. So before even going ahead to see what the question is saying, we should just find what this angle is. This particular angle will be what? 360 degrees minus 41, and that is 319 degrees. So we know that the angle of the major sector will be what? 319 degrees. Now, the area of the major sector is given by 74.5 centimeters square. We've been asked to calculate the radius of the circle. Now, we have looked at the angle there. We know it is 319. We know that the formula for finding the area of any sector at all is given as area of a sector. Since a sector is a portion of the area of the total of the entire circle, and what defines the portion is the angle. So we have theta over 360 times pi r square. All right, so that is the area of a sector. And in this case, we have been told what the value is. We have been told that it turns out to be what? 74.5 centimeters square. Now we've been asked to find our area. My approach to this will be for you to make r the subject of the formula. So this is really saying theta pi r square over 360 equal to 74.5. If 360, we multiply both sides by 360, we are going to have theta pi r square is equal to 74.5 times 360. Okay, now we have theta and pi here. If they go over to the other side, they will be dividing. So we're going to have r square equals to 74.5 times 360 over theta times pi. All right. And then our r, since it's been squared on this side, we do the opposite to get rid of the square. So we need to find the square root, and we'll do the square root of both sides. So r will be given by 74.5 times 360. We already know what our theta is. Remember, up here, we define what our theta is. Since the area given is the area of the major sector, and this is the angle for the major sector. So we know that our theta is going to be 319 times pi. I just want to reiterate, it's better you use your calculator value for your pi, or if you must approximate, you use 3.142. All right, so if you evaluate this properly, you're going to have to find the square root of 26.5 0.7619 and quite a number of other decimals. And that means your R is going to be 5.173 and so many others. To three significant figures, this is going to be 5.17 centimeters. So the catch to this question is for you to recognize that the area given is that of the major sector, but the angle given is that of the minor sector. That is why we had to subtract the 41 from 360 degrees to find the angle for the major sector. And I decided to make R the subject of the formula to minimize error due to approximation. Because if you start approximating early, your answer might turn out wrong. So please note that it is better to make what you're looking for the subject of your formula, and then you can work it out. All right. Okay, on to the next question. Here we are told that the diagram shows a sector of a circle of radius 8 centimeters. The length of the arc PQ is 6.4 centimeters. And we have been asked to find what? The area of the sector. Note, we have been given the radius of the circle, and we have been given the length of the arc. This is the arc here. The length of this is what is given as 64. So you need to work backwards, because to find the area of a sector, you need to find what this angle is. You need to know what theta is. So using your length of arc, you work backwards to find your theta. And when you have found your theta, then you use that value to find your area of the sector. I hope you understand. Okay, so let's find what theta is using this value we have been given. We know that the length of arc, the formula for the length of arc is given by theta over 360 times 2 pi r. All right. So this particular formula, we are told that when applied in this question, is going to give 6.4 centimeters. So what we need to do is make theta the subject of the formula, and then we use that theta to find the area of our sector. So making theta the subject of the formula, the numerator on the left-hand side becomes 2 pi r theta over 360 equal to 6.4. The 360 goes to join the 6.4, and the 2 pi r become the denominator. I hope you understand. This goes up here and this comes down here. So theta will be given by 6.4 times 360 divided by 2 pi. Our r is given, sorry, so we need to put that in. R is 8. So our theta is actually 6.4 times 360 over 2 times pi times 8. I'm going to simplify this. If you simplify this properly, you're going to end up with 144 over theta. Sorry, over pi. Why am I leaving it like this? I want to make my work easier later. If I evaluate this and I have an error, I'm going to carry the error into the next part of the question, and I'm trying to avoid that. So that is why I've evaluated it as 144 over pi. Okay, so you just cut all of this down. You're going to have 144 over pi. Now, area of sector. Area of sector is given by theta over 360 times pi r square. Okay, now we just found our theta as 144 over pi. So it's going to be 144 over pi times 1 over 360. These are 360 times pi times r squared. It's the same radius. So that is times r squared. So that's going to be 8 square. All right. This pi is going to cancel this pi. So we are left with 144 times 64 over 360. Look at how neat the numbers came out. If you try to evaluate here, you might not get it this neat. This is neat and tidy, and you're going to have your full marks. Easy peasy. All right. You evaluate this on your calculator, you're going to have 25.6. So the area of the sector here is 25.6 centimeters square. All right. So that is that with this two questions we're looking at in this part of the video. I hope you understand. Remember, here we had to do this because they were asking for the major sector. And in this particular question, we were given the length of the arc without the angle, and we had to find the angle first before we could find the area of the sector. Thank you for staying till the very end. Please give the video a thumbs up. Please subscribe if you haven't, and see you in the next one. Thank you.